if you are in AB, which you already are, okay, you only have to worry about one direction. If you were in BC, you'd be doing two axes at the same time. So this is really not going to be so bad. There's no vectors, okay? You just have to do one axis at a time. So it is either going to be a horizontal or a vertical axis. As a function of time, the letters that they will usually pick for position will be S of t, X of t, or X. Oh wait, I already put that. What's the other one? X, S, and F of X. Okay? Those are, or actually sometimes they'll use H of t for height. Okay? But every time they will label it with whatever letter they want you to use, so you should just match it. Okay? Now, the domain, when an object is in motion, usually you would say that time doesn't start until 0. So I'm going to put greater than or equal to 0 for time. They oftentimes will say it, but if they don't, if it's an application question, you would start at 0. Okay, initial position represents the position at time 0. So all that you would have to do is find basically the y-intercept. Okay, so if initial means at the beginning and the beginning is 0, then you would plug in 0. So, little baby easy example here. A baseball is thrown in the air. Its position in feet is given by, and then you have an equation. Well, then if I want to know the height of the ball at the beginning, I'd find x of 0. Yes? So it'd be 0 plus 6 times 0 plus 16 is 16. Now question, remember that we said that 16 is directional. So if it's a positive 16, that means the ball starts where? Above or below the origin? Above. So put right here, at time 0, the ball is 16 feet above the origin. Okay, just to kind of think it through, right? If it's
throw a ball starting 16 feet.
You're 16 feet tall and you're on, or maybe you're on a ladder. You're in the stands, trying to show off. Who knows? Okay, then it says, when does the ball hit the ground? Okay, well think about if I want the ball on the ground, what height do I want it to have? So I'm going to set x of t equal to 0. So 0 equals negative t squared plus 6t plus 16. Can I factor when my leading coefficient is negative? No, so I have to switch all the signs. Positive t squared, negative 6t, and then negative 16. Okay, from here, we need to find numbers that multiply to 16, that subtract to 6. Good. T minus 8, t minus 2. It would have to be plus 2, thank you. Okay, then from there, what are my t values? 8 and negative 2. Now, those would be measured in seconds. Now, let's talk about for a second why we got a negative value, because we're going to cross it out in a second. This is a what shape? Parabola. So it starts at 16, because our guy's randomly on a ladder. The ball goes up, the ball goes down. Right? Where does the negative solution come from? Yeah, on the other side over here, right? There's still a piece of graph, so it's giving you the one over here. Now, does that fit our model? No. But does it still happen in the graph? Yes. So we would cross that out and say 8 seconds only. Because remember, t greater than or equal to 0. Okay? So this is t equals 8. So far, so good? Okay. So that was all with position. The derivative of position is velocity. Okay, which is pretty much always going to be called v of t. They don't have any other random letters that they use. Okay, v is velocity, and it gives the direction of the object's movement on the axis. If your velocity is greater than 0, you're going to be moving in the positive direction. Now, think about if I'm on the x-axis, which way would be positive, left or right? Okay, right. And what about if I'm on the y-axis, which way, up or down? Up. V of t, yes, sir. Now, if my velocity is negative, that means I'm moving in the negative directions. But depending on what axis I'm on, that could mean that I'm going to the left or that I'm going down. Okay, but those are the only two axes they'll ever really put you on. Now, what if the velocity is 0? What is your object doing? It's not moving, which means it's at rest. So if your particle has a velocity of 0, that means at that moment it's at rest. Okay, to find the ball's velocity at any time, you're going to need to take the derivative. So we are going to continue to work through our basketball problem, or baseball problem. Okay, so what is the derivative of my equation up here? Negative 2t plus 6. And then remember that the 16 goes away. Now, on the AP test, if I put that, I get no points because it's not labeled. Yes?
Would we do x minus t or dt?
Oh, we're going to put both of those. Great. Okay, this is what I was about to say. Is you have to label and you have to be very specific. So what am I finding? Velocity equals. And then how did I find it with x? I did x prime. Okay, so you're saying velocity is the derivative of position, and this is what the derivative is. And you have to put all three. Okay, then it says at any time, so notice that's why I'm leaving the t in there. Now look at part C, it says find the initial velocity. What does initial mean? What time? 0. Very good. So I would find v of 0. And then from here, I would do negative 2 times 0 plus 6 is 6. Now, then it says to interpret. So, to interpret, you're going to give a ton of information, okay? T is for time, U is for units, and N is for the noun or whatever made-up thing they're talking about in the question. Okay, so you have to include those three things whenever you're interpreting. So I'm going to do this one for you. You would say at time, t equals 0 seconds. The baseball is moving, or you could say traveling if you like that better. 6, we said this is in feet per second, upwards. Now, how do we know that it's upwards? Because my 6 was positive. If it had come out to be negative, which is going to happen in part D, we'll do that in a second. So, let's do D now. We want the velocity at 5. That'd be negative 2 times 5 is negative 10 plus 6, which comes out to what? Negative 4. Very good. And then from there we'd say, okay, at time, t equals what? 5 measured in seconds. The ball is moving 4 feet per second downward. And where does the downward come from? Because of the negative. Now, don't put negative 4 feet per second downward. The direction comes from the negative. You would not also include it. Okay? Alright, physicsy people, what is the difference between velocity and speed? Velocity is speed with direction. Speed does not have direction. Think about on your car. Okay, speedometer measures if you're going forward or backwards, it only gives you how fast you're going. It doesn't have like a negative part for you to be going backwards, right? So speed is always positive. So it has no direction. And what mathy thing do you have that turns everything positive? Absolute value. So it's the absolute value of velocity. Okay, so it says find the ball's speed when it hits the ground. Well, then this is what I'm going to do. When did it hit the ground? Do we remember? 8 seconds. I'm going to find the velocity at 8, and then I'm going to do what to it? Find the absolute value. So I'd find, we already know when it hits the ground, we found it earlier, and then I'm going to find the velocity at that time and then turn it positive. Okay, so velocity was negative 2t plus 6. Negative 2 times 8 is negative 16 plus 6 is negative 10, but the absolute value bars turn it to a positive 10. Now, what does the negative tell us? That the ball was going down at that time. But speed, that's irrelevant. Okay, that would be measured in feet per second. Okay, your interval test is going to tell you where there's a relative min or max. So, if I'm coming here, you're going to have to set your critical numbers. Will be when velocity is 0, just like usual. Okay, but when do I use my model? Between what numbers? When does the ball take off? At what time? What time? 0. And when did it hit the ground? 8. So I can't have my number line going to infinities. That doesn't make sense. The time starts at 0, and once the ball hits the ground, it's dead. The ball doesn't keep shooting through the earth. That doesn't make sense, so you would stop using your model at that point. Okay. That doesn't count. The ball only stops. Pretend. Okay, so velocity equal to 0. I had a negative 2t plus 6. What can I take out? Negative 2. What's left over? T minus 3, which means my only critical number is 3. Now, in your head, if a ball was thrown up and then down, we know it's going to be a max. Okay, but pretend that you didn't know that. Okay, I'm going to plug in 1, because that's smaller than 3. 1 minus 3 is negative. Do I put a negative here? Positive, because why? You have a negative in the front, times another negative gives me a positive. Other side, say we pick 4. 4 minus 3 is positive, but multiplied with the negative in the front makes it negative. Those are the signs of velocity. We're not going to label it F prime anymore because we have a name for it now. And what does that tell us about the position? That it was increasing, good, then decreasing. So what type of extrema do we have at 3? A max. Very good. So it says determine when the ball reaches its max. We would say there's a relative max at t equals 3 because v of t changes positive to negative. Okay, now look at the second part of the question. We know the max happens. We know when it happens. How do I find the max height? What would I have to go back and do? You would have to go back and plug it into where? To the original. Very good. So I would have to find x of 3 in the original. So it's negative 3 squared plus 6 times 3 plus 16. 6 times 3 down here is 18 plus 12 and then minus 9. Negative 9, 25, yeah? Right? Okay? That'd be negative, yeah, it'd be 25. Right? Huh? Sure. Okay, how do we feel about that? Not so bad, right? Okay, let's do another one. Turn the page. Our goal is to get halfway through the packet, and then we're going to finish it tomorrow. Because if you want it to be on the ground, you want the height off the ground to be 0. So that's why. Okay, next one. So last time we had a ball. This time we just have a random particle. This is normally what the AP test will do, and this is why. If they give you something where you could use physics formulas to solve it, they're not going to give you any points. And they actually did that one time. It was throwing a ball up, and the kid had done it with physics formulas, and he got no credit. So now they'll make it like a random particle to try to make you not able to use those formulas. Okay, so it says we're on which axis? Y-axis. What time are we looking between? 0 and 6. What's our units? Centimeters measured in, time is measured in seconds, and then we have our equation. Okay, part A says to find the velocity at any time. That means I'm taking the what? Derivative. So I would put v of t equals x prime of t. And then I'm going to do it. So, derivative of t cubed blah 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 is what? 3t squared minus 12t plus, what about the plus 3?
0.
Constant, derivative is 0. Okay, part B says find when the particle is at rest. At rest means velocity has to be what? 0. Not plug in 0, but set equal to 0, right? So I would do 0 equals, take out a 3. What's left over? Minus 4t plus 3. Then I need numbers that multiply to positive 3 and add to negative 4. What would I pick? Yep, negative 3, negative 1. So my particle was at rest twice. These are my critical numbers. At rest, at 3, and 1. Set up your little line chart. Should I put arrows on both sides? No. What would I put on either side? 0 and 6. And then my critical numbers are 1 and 3. On the bottom, I'm doing velocity. On the top, we're making a conclusion about position. You need a pencil?
Oh, no, I have one.
Oh, you do? Okay. You're going to plug in 0 first. 0 minus 3 is negative. 0 minus 1 is negative. Times them together. Say I plug in 2. 2 minus 3 is negative. 2 minus 1 is positive. Multiply those together, be a negative result. And then last one, say I pick 4. Okay, 4 minus 3, 4 minus 1 are both positive, so they times to a positive as well. What was position doing? Use the calculus-y word. It was increasing, decreasing, increasing. Okay, part C says, yes ma'am?
Can you use 0 just because it's not a critical?
You can use 0 because it's not a critical number, correct. So if you wanted to plug in 0 instead of, I don't remember what we plugged in. Did we plug in 0? Yeah, but either way, whatever you plug in, as long as it's not a critical number, you're allowed to use it. Okay? When is my particle traveling up the y-axis? What intervals? 0 to 1 and 3 to 6. Very good. Because, pretend it said justify. How did we know that velocity was what? Greater than 0. Now, when is my particle traveling down the y-axis? 1 to 3. Because velocity was negative or less than 0. Good? Okay, E says find the max position. Where do I have a relative max? Is that automatically the winner? No. Now, this is where, on the AP test, they're not going to say absolute if they give you an interval. So if I'm looking from 0 to 6, you need to do a little chart. Okay, the numbers that we are plugging in are 0 and 6 because those are our endpoints, but we're also going to have to plug in 1 and 3. Now, if 1 or 3 didn't have a sign change, could I leave it off the chart in that case? Yes. But if there's a sign change, you got to put it. Okay, let's do 0 first. Ready? Where are we plugging into? Original position. So it'd be 0 cubed minus 6 times 0 plus 9 times 0 plus 3. What would we get? 3. Okay, next we're plugging in 1. 1 cubed minus 6 times 1 squared plus 9 times 1 plus 3. What do we get? 7. Good. Okay, next one. 3 cubed minus 6 times 3 squared plus 9 times 3 plus 3. Now, on your homework, do I care if you use a calculator for this? Absolutely not. Don't care. Okay, but on the AP test, they could give you numbers like this. Probably they wouldn't make it this annoying. Okay, so 3 cubed is 27. 6 times 9 would be 54. Then another plus 27. Then a plus 3. What did 27 and 27 add to? 54, but then I have a minus 54. What happens? What's left over? 3, yeah? Okay, then last one, we need to plug in 6. 6 cubed. 6 times 6 squared. 9 times 6 plus 3. Now, on the AP test, I want you to think, just don't try to find 6 cubed, even though it is 216, you're right. Okay, listen. If I have 6 cubed and then 6 squared times 6, are those different? This is a 6 cubed minus a 6 cubed, right? What's going to happen? Cross them out. That's a 6 cubed too, because it's a 6 squared with another little 6 friendly. Okay, so those cross out. Then really, I just have 54 plus 3, which is 57. Okay? From there, what is my maximum position? Okay, max position is 57. It occurs at x equals 6. And I'm actually going to make it t equals 6. Now, 57 is measured in what? Centimeters at 6 seconds. Okay, now, sometimes they'll ask you for the height, sometimes they'll ask you for the time, sometimes they'll ask you for both. I would just always answer with both so that you don't actually put one part and not the other if they ask for a specific one. What's the minimum position? Okay, minimum position is 3. It occurs at t equals 0 and 3 seconds. Okay? Then remember that we said that is a sufficient justification. You don't have to do more than that. Okay, next part. These are new. It says, determine whether an object is traveling towards or away from the origin. You have to consider 2 parts of its, situation. You have to look at the position and you have to look at the velocity. This is why. Actually, let's do it and then I'll explain why. So it says, determine whether the particle is traveling towards or away from the origin at 0. I'm going to find the position at 0 and the velocity at 0. Now, position's already in my chart. What's the position at 0? 3. Okay, what does that tell me? Remember, I'm on the y-axis here. Here's the y-axis. Let's say here's the origin. If I'm at 3, that means I'm 3 units above the origin. So here's my particle. Okay, its velocity is going to determine whether I'm going up or down, right? Okay, if my velocity is positive, which way is my particle going? Up. Is that towards or away from the origin? If I'm going up, I'm going away. But what if I'm above and I have a negative velocity? Then I'd be going towards. That's why you have to look at both. Because if I'm above and I'm going up, I'm going away. But if I'm above and I'm headed down, I'm going towards. So plug in 0 to your velocity. Plug in 0 to your velocity, and we'd have 3 times 0 minus 12 times 0 plus 9, which is 9. So which way is my particle going to be moving? He's going to be going up, which means he's going away. This is how you would explain that. You would say at 0, x of 0 is greater than 0. It's positive. So particle is above the origin. And v of 0 is positive. So he's moving up. Therefore, away. So my position is greater than 0. That means that I'm above. My velocity is 0. That means I'm moving up, which means that I am moving away. Okay, letter H. Determine whether the particle is traveling towards or away from the origin at 2. What two things do I need to know towards or away? Position at 2 and velocity at 2. Now, unfortunately, 2 is not in our chart, but we can find it. So it'd be 2 cubed minus 6 times 2 squared plus 9 times 2 plus 3. So that's 8. That'd be minus 24. And then if that's 21, negative 24 and 21 is negative 3, so plus 8 is 5. So my particle is where? Above or below? He's above. So I'm going to draw my little number line here. Here's my origin. And my guy's at 1, 2, 3, 4, 5. He's right here. Now my velocity would be 3 times 2 squared minus 12 times 2 plus 9. So that'd be 4 times 3 is 12 minus 24. And then plus 9. Negative 12 and 12 and negative 24 make negative 12, plus 9 is negative 3. So although my particle is above, his velocity is negative. That means which way is he going, up or down? He's going down, which means that he's going towards or away. He's going to be going towards until he passes the origin, because he's above, but he's headed down. Yeah? So I would say x of 2 greater than 0. So particle is above. V of 2 less than 0 means traveling down. Therefore, towards. Okay, one last new thing to cover, and then we're going to do one more example together, then you'll have time to look at your homework. Okay, so it says, down here at the bottom, velocity is the derivative of position. In the graph, then, what is it? The slope. Now remember, there are two kinds of slope. There's your tangent slope, which is a derivative, but there's also an average slope. Do you remember average slope? That's your average rate of change. So here's the difference. If it's the velocity at 4, you would be taking the derivative, plugging in 4. But if it's the average velocity, you would be doing the average rate of change, of 0 to 2, or whatever interval they gave you. This one just happens to say 0 to 2. So here's the difference. If it's the velocity at one time value, you take the derivative, plug it in. But if it's over an interval of time, you'd be doing this one. Yeah? Okay, and then make sure it's average. Okay, that's your hint that it is your slope formula and not the derivative. Okay? Then I'm also going to put that this is at a time value. This is over an interval. Okay? Alright, we're going to do one problem all together, then y'all are going to look at your homework. So next one, read through it. And do part A through F. A through F. How do you find the velocity at any time? You take make sure you label. And then when you want to know if he changes direction, you're doing a sign chart, right? Because the direction is determined by the sign. So if the sign changes, the direction changes. And then you want to put x prime to the first. And then take the derivative. Yep, and you take the derivative. Okay, so the first thing on your paper should be this. V of t equals x prime of t, and then you should have 3t squared minus 12t. That's part A. Part B, we want the squirrel to change direction, then we need to set his velocity equal to what? 0. Take out a 3 and a t. That'd give me t minus 4 left over. Set up your number line. Now, did they tell me when to stop using the model? No, most of the ones on your homework are like that. That's because I made them and I forgot to put it on there. So, if they do that on the AP test, you follow whatever they gave you. So, this is going to continue to infinity. Now, does it really make sense that your squirrel can run forever? No. Okay, eventually he dies. But we don't know when, so sad news. Okay, 0 and 4. Now, will I be able to use 0 in my sign chart if it's a critical number? Can't plug it in. You'll have to pick something else. So let's pick 1 in the middle. What is 1 minus 4? Times 1 outside? Negative. Pick a number bigger than 4. Say you pick 5. 3 times 5 is positive. 5 minus 4 is positive. And then remember that velocity tells me stuff about which way he's going. His position was decreasing, then increasing. So when did our squirrel change direction? At 0 and 4. Because velocity changed sign. Now, did they ask what kind, whether it was a min or a max? Then we don't have to specify. Okay, part C says, when was the particle traveling to the right? Which interval would that be? 4 till poor squirrel dies. Okay, 4 to infinity because v of t greater than 0. When was the squirrel going to the left? 0 to 4 because v of t less than 0. Okay, next part says, when is the squirrel farthest to the left in the first 5 seconds? If I'm only looking at the first 5 seconds, Is that one time or an interval of time? Then you're doing absolute. You need to do a candidate's chart or a candidate's test. So set it up. Who goes in the chart? 0. First 5 seconds. So 0 till 5. And then what was my critical number there was a sign change at? 4. Where am I plugging into? The original.
Did you not do anything that one? Like you do negative because it's negative time.
Yes,
Yeah.
exactly.
Yeah.
Because remember, for like a squirrel, his time can only be 0 and up. Yes.
How did you know that there was a sign change at 0?
Okay, so good question. Listen, is there a sign change at 0 if the squirrel wasn't running before that? So there's actually not a sign change at 0, but it's an end point. Yeah? So 0 and 5 are my end points. For part... Oh yeah, I guess we really shouldn't include 0, because is there a sign change at 0? Okay, that's a good question. Let's just take that off. Probably really you should only put 4. Because at 0, the squirrel didn't really change direction because he just started running, right? Thank you for that. Okay, so go to your position. We're plugging in 0 first. So it'd be 0 cubed minus 6 times 0 squared plus 1. What is it? 1. Okay, next one, we're plugging in 4. 4 cubed minus 6 times 4 squared plus 1. 4 cubed is 64. Minus, that'd be 16 times 6. That'd be 6. Okay, I can't do math in my head, okay, so don't hate. Okay, minus 96, then plus 1. And then from there, what's 64 minus 96? That'd be 2, 3, 32, yeah? See, look, you can rewind your life to elementary school any day that you want.
That's how like divide stuff.
And then what's negative 32 plus 1? Boom, got it. Okay, then we need to do 5. Now on the AP test, they'd probably make these numbers, not as hard. But these are very manageable if you had to do them. Okay, so 5 cubed is 125. Minus 5 squared is 6 times 25. 6 times 6 quarters is worth how much? 150. What's 125 minus 150? Negative 25 plus 1? Negative 24. Okay, all of that works. But on your homework, should you do this? Calculator, okay? Okay, so when was the squirrel farthest to the left? When was his position the smallest? Okay, at 4. Now, if you pay really close attention to the question, what are they asking for this time that you have to answer? When, okay? But if they're saying how far was he, you would have had to say the y value. So I'm going to say both. Absolute min is negative 31 at t equals 4. And if your chart is labeled, then you don't have to explain. Okay, letter F. When is he farthest to the right? So it'd be at 0. So my absolute max is 1. It occurs at t equals 0. Okay, at letter G, at 5 seconds, is the squirrel moving towards or away from the origin? Explain. Okay, what 2 things do we need to answer towards or away? The position and the velocity. My position is what at 5? We already found it. Negative 24, it's in our chart. And then my velocity at 5 would be 3 times 5 squared minus 12 times 5. What is 3 times 25 here? 75 minus 12 times 5 is 60. And you don't even care about the number, you care about the sign. If I do 75 minus 60, how's it going to come out? Positive. So I'm not even going to find the number. I know it's positive. So draw your little power line. Where do I draw my squirrel? If he's at negative 24 for his position. He's on the left. Okay. He's holding a nut. Okay. Happily running. He looks like a dinosaur. Okay, and then which way is he going if this is positive? To the right. So is he going towards or away? Don't look. Okay, you're jealous of this squirrel. He's a snack. At t equals 5, x of 5 is less than 0. Where's my squirrel then? So squirrel is on the left, but v of 5 is greater than 0, so he is traveling to the right. Therefore, he's going towards. You get it? But you have to find both, because if you only know which way he's going, that's not enough information to answer the question. Now at 6, what would we have to do? Find the position and the velocity, then determine. We're going to skip it though in the interest of time. Okay, part I. Find the average velocity over 0 to 5. Are they asking for a slope? Yes. But are they asking for the slope at one time or over an interval of time? An interval, then you should be doing a rock. Okay, because it is still a slope, but it's an average slope. That's what you learned in Algebra 1. So you would have done x of 5 minus x of 0 over 5 minus 0. What was x of 5? We already found it. Negative 24. What was x of 0? We already found it. 1. Negative 24 minus 5 more is negative 25. Divide that by 5. What is my average slope on that interval? Okay, this is a velocity though. It's an average velocity. So it would have been measured in feet per second. Now let's talk about for a second, how do we know it's feet per second? What was position measured in? Feet. And what was time measured in? Seconds. So when you divide those, does it make sense you get feet per second? Now, what does the negative tell us about the squirrel? Which way is he going? He's running to the left at 5 feet per second. Make sense? Okay, we're going to finish this tomorrow, but I want you to do number 1 off your homework. Give it a shot. Yes. Because think about it, you want the slope, right? So you can't take, if you take the slope of velocity, then you're taking the second one. So you're taking the slope of the function, and so that's what should go into the formula.
So you're taking the slope of the position,
Yes, which is velocity, that's right.